This is section 11.5, video 2 on partial fraction decomposition. And this is going to match problems 3 and 4 in your packet. We know from the first video that the first thing we need to look at is to see if the degree in the numerator is more than the degree in the denominator. That is not the case, so we don't have to worry about any long division. So we go to step 2, which is to factor the denominator. And the first thing we can factor out of here is a GCF, which gives me x squared minus 2x minus 3. And that is a very easy polynomial to factor as x times x minus 3 times x plus 1. And these are what's going to give me the denominators for my partial fraction decomposition. So each one of these fractions takes one of these factors. And because these are linear factors, then we are just going to put a, b, and c on the top, and we're ready to go to the next step, which is to clear out the fractions. The fractions will be cleared out by multiplying by the least common denominator, which happens to be this x times x minus 3 times x plus 1. Now, when we multiply over here, this denominator cancels totally with this denominator, and we are left with 7x plus 3. Over here, I'm going to cancel out this x with this x, and I'm going to move this little bar so we've covered up the x, which shows that it's been canceled out. So that is gone, and what we have now is a times x minus 3 times x plus 1. Remember, we're not FOILing anything out, we are just writing these factors here. Come over here, I'm going to cancel the x minus 3 with this x minus 3, so that's gone. So what remains is b times that x times x plus 1. And then for this third denominator, this x plus 1 is going to cancel with that x plus 1. So I'll move my bar over here. And what remains then is c times x minus 3. So we have successfully canceled out all of the denominators, and we are ready to go to the next step, which is to let x equal whatever values are going to make this arithmetic easier. Because we have 3 distinct linear factors, those factors will lead directly to what values I let x equal. If I set this denominator equal to 0, I get letting x equal 0 is a good idea. Set this one equal to 0, I get 3. Set this one equal to 0, I'm going to get -1. So those are the values I'm going to substitute in for x to continue this problem. So if I let x equal 0, I'm putting 0 in for all of these x's, all of them. And a lot of stuff's going to cancel out. 7 times 0 plus 3 is 3 equals, put 0 here, 0 minus 3 is -3. 0 plus 1 is 1. So this is a times -3 times 1 is -3a. Let's see what happens over here with the b. Put a 0 right here for x. 0 times all of this gives me 0, so b has canceled out. Same thing happens with this c right here. 0 in for x, 0 times c gives me 0, times the rest of this gives me 0. So what happens is the b and the c have canceled out, leaving just this little equation to solve. Divide both sides by -3, and we get a equals -1. Then, because I let x equal 3, let's get this erased. I'm going to put 3 in for every single x you see. Here, 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 and here. And do the arithmetic. 7 times 3 is 21, plus 3 is 24. If I put 3 right in here, 3 minus 3 is 0, and 0 times all of this gives me a 0. I'm not going to cancel all that out because I need that on my next step, but that would be 0, so there is going to be no a. Put 3 over here. 3 times b is 3b, times 3 plus 1 is 4, which gives me 12b. Let's see what happens over here. If I put 3 in over here, 3 minus 3 is 0. 0 times the rest of this is 0. So the c part has canceled out. I have a simple equation right here, 12b equals 24, or b equals 2. And then I need to erase and do all of that again. This time I will let x equal -1 and see what happens to my arithmetic. So if you put -1 in here, 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 it's a hassle, but it's a good idea to write all this stuff down and have all your arithmetic in front of you. So 7 times -1 is -7, plus 3 is -4, equals. If I put -1 here, I'm not going to worry about it just yet, because -1 plus 1 gives me 0 here. 0 times all of that stuff is 0, so the a is out of there. If I put -1 here, -1 plus 1 is 0, times all of this stuff is 0. So in other words, there'll be no a, there'll be no b, but over here, c times -1 is -c, times -1 minus 3 is -4, -c times -4 is +4c, divide both sides by c, and c equals -1. Those are my values of a, b, and c that go with those particular denominators. Now I've just got to be careful where I put these. I have a equals -1. Where was a? A was on top of plain old x, so -1 goes right here. B is 2. Where was b? B was on top of x minus 3, so 2 goes here. And over here, c is -1. C is that last fraction, and I'm right here. And that is the partial fraction decomposition. Now, before I go to the next actual problem, I need to explain something, and that is, back in the old days, when you did Algebra 1 or Algebra 2 with adding fractions together, you know you need a common denominator. Well, for x minus 1 and for x minus 1 squared, the common denominator is x minus 1 squared. I'll come back to that in a minute. If you're going to add these two together and each of them already had the denominator x minus 1 squared, then the common denominator is very simply x minus 1 squared. Okay, so why does this matter? Remember what we're doing. We are doing partial fraction decomposition. We are working backwards. We have this denominator with some random numerator on each of these. We're looking at the denominator. Each of the denominators says x minus 1 quantity squared. We don't know which situation produced this common denominator. Was it this, where it was x minus 1 and an x minus 1 squared? Or was it this, where it was x minus 1 squared for both? Since we don't know, we have to account for both possibilities. So under this possibility, over here, we're thinking, it could have been x minus 1, it could have been x minus 1 squared, or it could have been both of them being x minus 1 squared. Since we don't know, we have to lay out our factors like this. We have to lay out x minus 1. We have to lay out x minus 1 squared. It might not really be plain old x minus 1, but because it might be, we have to lay it out as a possibility. And of course, there's the x plus 1 because of that factor right there. So this is what's known as a linear factor repeated. Linear factor repeated. What's that mean? Look at x minus 1 squared. X minus 1 squared is x minus 1 times x minus 1. These are linear factors. They are the same linear factor, therefore this is called linear factor repeated. So the rule says because this is a linear factor that is repeated, we must account for the linear factor and all of its powers. What it means by all of its powers is this. Because this says x minus 1 squared, we have to build up to the squared. X minus 1 to the first, x minus 1 squared. We stop at x minus 1 squared because the original denominator stopped at x minus 1 squared. But pretend this had been x minus 1 cubed. Then I would have to lay out the possibility that there's an x minus 1. There would be a possibility of an x minus 1 squared and the possibility of an x minus 1 cubed. That's why it says we must account for the linear factor and all of its powers. All of its powers up to this power that was in your original denominator. Clearing out the denominator by multiplying by the common denominator produces this. The x minus 1 squared times x plus 1, of course, cancels entirely, and we have x squared. And over here, I'm going to use this little black box here to show what's going to be left and what's going to be gone. When I want to multiply by this denominator, this x minus 1 is going to cancel with one of these. So I'm going to put my little black box right here. And this shows you that what I've got is a, and what's left up there in blue is x minus 1 times x plus 1. Plus, come over here and move the box around. when I am going to cancel x minus 1 squared, that means that x minus 1 squared is going to cancel with that entire factor, including the exponents. I'm covering that up best I can. And what is left here is b times x plus 1. That's it. So I've gotten rid of that denominator and that denominator. Third time through, I'm going to cancel the x plus 1. Well, this time I don't really need the box because I'm done. X plus 1, and what's left is c times x minus 1 squared. So we have gotten rid of all of the denominators. So now we're ready to start stuffing in a value for x. I have chosen x to be 1. I have chosen x to be negative 1 because if I put 1 in certain places, it creates a 0, which makes the arithmetic easier for me. If I put negative 1 in certain places, it also creates 0, which makes the arithmetic easy for me. So if I say x equals 1, I'm putting 1 in every place you see an x. And I think it's a good idea to actually write this out, write the numbers underneath, and do the arithmetic by hand rather than try to do a bunch of steps in your head. 1 squared is 1. If I let 1 be x, 1 minus 1 is 0. This is going to be all 0. So all of the a part goes away. If I put 1 right here, 1 plus 1 is 2, which gives me 2b. And over here, 1 minus 1 is 0. So all of this goes to 0. So all I have is 1 equals 2b, divide by 2, and we have a value for b of 1/2. So let's erase all of this stuff and change the value that we're using for x. Now we're letting x equal negative 1. Be careful, that's the quantity negative 1 squared is 1. So I'm putting a negative 1 in place of all of these x's that you see. Negative 1 minus 1 is negative 2, but negative 1 plus 1 is 0 right here times all of this stuff gives me 0. Negative 1 plus 1 is 0 times b gives me 0. So a and b are wiped out. Over here, it's negative 1 minus 1 is negative 2 squared. So this is 4c. Divide both sides by 4, and c is 1/4. Now, we don't have any more good numbers to stuff in for x. We can pick whatever number we want, but the only two numbers that made the arithmetic easy for me, that produced some stuff to cancel out, were 1, negative 1. So we get to pick whatever we want. We could pick 97, we could pick 55, but I think a good number in this case to pick is 0. That's pretty much a general rule. If you have not used 0 already in one of your other values, then I would let x equal 0. If we'd already used 0 and you already used 1, maybe you pick negative 1, maybe you pick 2. So just pick something that would make the arithmetic fairly easy for you. So I'm letting x equal 0, so that's going to be 0. Put a 0 here, 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 and here. So this is a times 0 minus 1 is negative 1, 0 plus 1 is positive 1. So this is a times negative 1 plus 1 gives me negative a. Over here, 0 plus 1 is 1 times b. So it's b times 1. So I'm running out of room here. This stays b. I've got a negative a. I've got a b. And over here, put 0 in here. 0 minus 1 is negative 1. Squared makes a positive 1. So this is just c. So putting all of those together in an equation, I have 0, because that's what that is right there. 0 equals negative a plus b plus c. Stop the video and look back and see why I have a, b, and c left instead of canceling things out like I had over here with the 1 and the negative 1. So it looks like, oh, we're in trouble. We have 3 variables, but we do know what 2 of those variables are. So this is 0 equals negative a plus b, which happens to be a half, plus c, which happens to be 1/4. So if I get a common denominator and add a half plus a fourth together, I get 3/4. And if you can't do the arithmetic in your head and get a common denominator, use your calculator. A half plus a fourth, change it back to a fraction. Add a to both sides, gives me a equals 3/4. Now be careful where you put these things. It's not the first thing I found goes on the first fraction and the second thing goes in the second fraction. It's a is 3/4. A was over the first denominator, so that's 3/4. What's over the x minus 1 squared is b, which was a half. And what was over the plain old x plus 1 is the c value, which is a fourth. So that is my partial fraction decomposition. This is perfectly acceptable for MATLAB, but you may be in a different course with a different book that's going to ask you to simplify even further, where these denominators here will come down to the bottom. If I were to go through the steps of simplifying a complex fraction, you'd see that's what happens. So you could write it as 3 over 4 times x minus 1 plus 1 over 2 times x minus 1 squared plus 1 over 4 times x plus 1.